I'm going over some of the problems from Chapter 7 homework. 45A, the average national math scores, F of t, for 17-year-olds can be represented as a function of the national science scores, t, by F of t, the function where input is t, equals 0.8 times t plus 72. So what does this mean? Well, first of all, let's graph it, okay? I can tell by the questions that come in B and C that we're going to need the numbers to go into the 300s. So I played around with my graph and I came up with two squares standing for 30 to fill into the space I have. In general, you want to have the domain and range of your data fill up as much of the graphing space as you can. It just gives you a better look at your data and a better, you're looking for a visual display of what's going on. All right, so on the x-axis is the science scores. That's the independent variable, the explanatory variable, that's the input, and this is what t is, okay, the science score. On the vertical axis is the math scores. Okay, so you've got f of t and t. Now what does the 0.8 mean? The 0.8 means that for each increase of 1 point in the science score, the predicted, now the key word here is predicted. This is all based on linear regression, which we're going to talk about later. Okay, so not the actual math score, but the predicted math score increases by 0.8 points. Okay, now, by the way, I'll talk about how I did the graph in a second. All right, so I'm talking about the meaning of the equation now. Okay, so, and what is the 72? If the student scores 0 on the science test, the expected math score is 72. Now, nobody is going to get a 0 on the science test. If you show up for the test and you can hear thunder and see lightning, you're going to get a minimal score of probably like 100 or something like that. Okay? Now this is important to remember because the domain, that is the science scores, begin and end within a certain spread, and they're certainly not going to include 0. Now I have 0 on the graph here because I wanted to graph to 72, but in actuality the domain would never go near 0, and the range would never include 72. In other words, the range would be being the predicted math scores. Okay, so just keep that in mind. Use your common sense when you're working with stuff like this, when you're working with linear regression, a model explaining something in reality, and don't go thinking, well, if you get 0 on a science score, you get 7. Well, no, that's just how the model works out, but in actuality, 0 is not in the domain. Nobody's going to get a 0 on the science test. Okay, but anyway, that's what the model means. Now, how did I make the graph? Okay, so I laid out the two axes. I made the scale the same, okay, going across and going up. 2 squares is 30 points. Now, I base this on the fact that I would expect that the overall scores for the two tests would have the same spread. Okay? Now, how did I come up with the slope? Well, the slope is 0.8. That means 8 over 10. So I went here and I counted 10 squares over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then I went up 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay? So here's my point, and then I did the same thing again. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then I went up 8. 1, 2, 3, 4, 5, 6, 7, 8. I put another point right here. Okay? And then I just drew a line connecting the points, and there's my line. Okay? So that's 45A. That's how I made the graph and how I interpreted the function in the context. All right, that's 45A. Let's look at 48D. Okay, and let me get 48D here on the screen. Okay, let me get another hand function here. 48D. Okay, babysitting. Christina earns $7.50 an hour babysitting. Okay. Now choose 5 values for the number of hours Christina could babysit. You can half an hour, 2.5 hours, etc., whatever you decide. Okay, this stuff is pretty easy. 48D. Does it make sense to connect the points in your graph with the line? In other words, is the amount that Christina, the number of hours that she works and the amount that she gets paid, is it discrete? That means is it a bunch of separate points? Well, it makes sense to connect the points with the line because Christina could work just a fraction of an hour. Okay, like riding in a taxi. Okay, I think it's in tenths or something like that. I mean, it's not continuous. You know, she's not going to work a millionth of an hour or a billionth or a trillionth, which is what you really have with a continuous line. But she could work small enough fractions so that in actuality it would make sense, using your common sense, to connect them with a line, even though, you know, she's not going to work pi hours, right? Okay, nobody's going to pay her pi times whatever her babysitting rate is, $7.50 or what have you. Okay, all right, but we will connect them. So that's 48D. 52. All right, write a question. A classmate graphed a set of ordered pairs and used the vertical line test to determine whether it was a function. Write a question to help her decide if the same strategy can be applied to a mapping. Okay, well, let's look at a mapping. I just made one up here. Mapping, domain and range. I threw in some numbers, okay? All right. Each member of the domain should have one arrow and only one arrow going from it to a not a relation, to a range. That should have, what am I doing? That should be range. The relation is the whole set of points. Going from it to be a relation. Oh, to be a function. Going, should have one arrow going, I see my mistake here, from it to be a function. Okay, so here's 1. 1 can have an arrow going to 5. So there's 1 input and 1 output. 1 can't go to 5 and 6. Okay, that would be 1 input and 2 outputs. Remember, we don't want to look at the temperature and see two different temperatures. Okay, I don't want to look at at 3 o'clock in the afternoon when I'm driving my car and I look at the gas meter. I don't want to see 2 different answers for how much gas is in the tank. Okay. I don't want to look at a clock on the wall and see 2 different times. All right. So 1 input, 1 output. So this is not function. Okay. Now remember, you could have every member of the domain going to the same range member. This is okay. This is a function. Okay. This would be graphed as a flat line. All right, flat lines are functions. They're fine. Vertical lines are not. Okay, if any member of the domain has more than 1 arrow going to the range, it is not a function. If any member of the domain. Okay, so you can't have multiple arrows. You can have multiple arrows going to the range. You cannot have multiple arrows going to any member of the domain. So that's a question. Okay. Are there multiple arrows coming from any member of the domain? If there are, not a function. Okay, now, let's see, 53. If f of 3b, I didn't answer this one here, so let's see if I'm just going to talk through it. Minus 1 equals 9b minus 1. Find one possible expression for f of x. Well, the only thing I can say for sure, notice the answer is 3x plus 2. You don't know what the rule is, okay? You don't know what f of x is, except there's one thing that you do know, that first term is going to get multiplied by 3. I don't know how they come up with the second term, and I couldn't really guess on that. So, but we know for sure that if x is the input, one of the terms is going to be 3x coming out. Now, I don't know, that second term could be anything. It's going to be a constant, but it could be anything there because you don't have the rule for it. So 3x plus 2, 3x plus 1, 3x minus 1. Oh, but the main thing is the first term's got to be 3x. I'm not going to ask you a question like this on the test, okay? It's kind of a, I don't know. It's not a question I'm crazy about. It's okay. You know, it's the hot problem, so I want you to do them all. I don't know. Okay. 58. Let's go to 58. All right, this is review. Everybody's crazy about review. Okay, 58, geometry. Good old geometry. Now, what's going on here? Okay, now we have to make an assumption here, which we normally don't make, and that is that the big triangle is a right triangle. We got these little guys. We got this triangle right here. We got this triangle right here. And then we got this big triangle. The big triangle does not have the little right angle symbol on it, but nevertheless, we are going to assume it's a right triangle. Okay, so then we have three similar triangles. Okay, they've all got the same angles. These are same angle, and they all have this angle in common here. Okay, so they are similar by angle, angle, angle. They got a right angle, and they got this angle. These angles here are all going to be the same, and that angle's the same. Okay, they're similar, which means that ratios of corresponding parts are equal. So what ratio do we have? We have 4 plus 6 plus 2. So the hypotenuse of the big triangle is 12, and then this perpendicular side, which is, I guess we call it the long leg. Okay, we have 12 over 9, or 4 over 3. This ratio is 4 over 3. Okay, so I'm not going to bother computing this hypotenuse here, but here's x. Well, the hypotenuse here is 4, so x has got to be 3, because the ratio is going to be 4 over 3. So x equals 3. And that's that for the questions I was asked about. If you have, if this helps, great. If you have any other questions, let me know. And that is it. So it's down here. Sorry, gotta stop this thing. Okay, here we go.